Start.
Good afternoon, Vanessa. Today we are going to discuss one of the main topic in the discrete mathematics, that is nothing but the Chinese remainder theorem. In this Chinese remainder theorem, this theorem is very important for your point of view, exam point of view, and your applications of Chinese remainder theorem are very useful in the competitive exams. So here now we are going to focus on the applications of the Chinese remainder theorem. So here in this Chinese remainder theorem, we are going to consider the more than the one congruences. More than one congruence. Congruence is nothing but the equivalent relation. Congruence is nothing but the equivalent relation. So in general, we will discuss the congruence is nothing but, here we are going to define congruence. A is congruence to B mod M. B mod M. Here that is nothing but M divides the difference of A minus B. Congruence definition. Let us consider the two elements, two integers A and B. M is a fixed positive integer, and we are going to relate this, equate these two integers by using the congruence. How it would be? A is congruence to B mod M under some modulo fixed positive integer, which is nothing but M divides the difference of A minus B. Okay, for example, if you consider 4 is congruence to, or else 6 is congruence to 2 mod 2. 2 mod 2. So here M is nothing but here 2 divides the 6 minus 2, which implies 2 divides the 4. Here, according to the definition of the divisibility, what we can write this thing as a 4 is divided by 2. Then we can say that this 6 is congruence to 2 mod 2. Okay, this is a basic concept, congruence definition. Now we are going to discuss more problems based on the Chinese remainder theorem. In this Chinese remainder theorem, first we will consider the more than the two congruences. More than the two congruences. By using this Chinese remainder theorem, we will get a polynomial is one. Then also we can say the polynomial is a linear polynomial. Here, as same as here, linear congruence. If the degree of the congruence is 1, then we can say that such congruence is nothing but the linear congruence. Let us consider the linear congruence depending upon the Chinese remainder theorem, that is nothing but mkx is congruence to bk mod mk. As we find out the b1 value and m1 value, substitute all these values in this linear congruence. m1 in place of the case, first substitute k is equals to 1, we will get the m1 into x is congruence to b1 into mod m1. Then here m1 value is what? Here from this m1 value is where here this m1 value is 20. Substitute here m1 into x is congruence to b1. b1 is nothing but 1. And mod m1, small m1, that is nothing but 3. So here 20 into x is congruence to 1 mod 3. And in the next step of the Chinese remainder theorem, as we have to find the value for the x, we are going to consider the x is equals to 1. In x is equals to 1, substitute here in the place of the x substitute 1, we'll check whether that value may be divisible by the 3 or not. How it would be? 20 is congruence to 1 mod 3. So then, according to this definition of the congruence, we may write like this. This is nothing but 3 is divided by 20 minus 1. And we need to check whether 3 divides the 19 or not. 19 is divided by 3 or not. So that's why here we are writing, according to the definition of the congruence, 3 does not divide the 19. In the next case, here we are not getting the proper value for the x. So let us assume there exists another value, that is nothing but x is equals to 2. Substitute here in the place of the x is 2. What you are going to get here? 40. This one is congruence to 1 mod 3. Same procedure whatever we applied for the x is equals to 1. So that is nothing but 3 is divided by 40 minus 1. we have to check whether this the difference of these two equals to 2 and m2 dash is equals to 2. Next here, in the Chinese remainder theorem, our main concept is that we need to find the x value. What is the exact x value? X is equals to b1, m1, m1 dash, m2 dash and n2 dash, b3, m3, n3 dash. So in order to get this value, we are doing all these things. So first consider, in the next step, consider the next congruence, that is nothing but the linear congruence. M3 is into x is congruence to b3 mod m3. So here 12 into x. X is nothing but here we are, as we discussed in the previous two congruences, x is equals to, first we have to put the x is equals to 1, then 12 into x is congruence to 3 mod 5. Check whether this 5 divides the difference of these two. That is nothing but here 5 divides the 12 minus 30. It is not possible according to the definition. So 5 does not divides the 11. So next consider here, since we are not getting the value proper, this linear congruence does not satisfy the divisibility definition. So we have to proceed to the next step and put x is equals to 2. That is nothing but here 12 into 2 is congruence to 3 mod 5. Then 5 divides the 24 minus 3. What is the difference between the 24 and 3? The difference is 21. 21 which is not divisible by the 4. Fine. So that's why we have to move to the next step, that is nothing but x is concrete. X is equals to 3. Substitute here in the place of the x 3, then 12 into 3 is congruence to 3 mod 5. Again we need to follow the same procedure as we did for the first congruence, second congruence and as well as the third congruence. Here also we are not getting the this 5 does not divides the what is that here 33. So here that's why we have to proceed to the next step. That is nothing but put x is equals